want to welcome everybody to our podcast today. I'm Dale Wren, the Executive Director of the Lime Association, and
I'm Larry Pierce. I am the Senior Manager of Civil Market Development for LaWast, one of the members of the Lime Association of Texas.
We're going to talk today about treatment guidelines for soils and base and pavement structures, and this will be a very short podcast, but hopefully be very informative to you. I want to first of all thank our members of the Lime Association, Austin White Lime, LaWast North America, and Texas Lime, who are the three companies that make up the Lime Association of Texas and to make these podcasts possible. The topics we're going to cover today are the benefits of soil stabilization. We're going to talk about TxDOT stabilization guidelines and talk about different types of soil stabilizers. Some of the benefits of soil stabilization we're primarily talking about with lime is that it eliminates the excavation and disposal cost. It provides a stable and uniform layer of paving structure. One thing that all pavement structures like is uniformity. We don't want hard spots and soft spots in the pavement. So that's one goal we always have. A major benefit that we get out of the lime is it decreases the expansion and swelling of the soil, which can be a major issue, particularly with swelling and when you get into high PI clays. There's a major problem in construction throughout Texas. It improves the foundation support. So we're looking again for just uniform support, and achieves long-term strength and performance. So we'll talk a little bit about pozzolanic action and how you gain strength over time when you use lime with high PI clays. I want to talk a little bit about it, just to show a typical flexible pavement structure. You know, a flexible pavement structure, and from a pavement design standpoint, starts with the asphalt surface typically has a modulus of around 500 KSI. Typically right underneath that you'll have a granular base material, and these are just approximate values, but I have a modulus in the 50 KSI value. If you look down at the very bottom of that, particularly when you're talking about clay soils, the raw subgrade will have a modulus in the range of about 10 KSI. So our goal when we're trying to modify with lime, in particular with clay soils, is to get that modulus up closer to what the base is. So when we modify or stabilize a clay, we're raising that modulus but up into the range of 30 to 50 KSI. So it's going to act a lot more similar to what the base material is. Now our goal here is to increase the strength, but we're not trying to build a rigid pavement. These pavements are designed to still remain flexible. Again, the goal is to build some strength, but we still want it to be at the same time also remain a flexible pavement.
And I think that's why the term subbase is used, because what you're doing is you're taking that raw clay subgrade soil, and rather than cutting some of it out and bringing in additional material, you're actually able to create a base layer underneath what we consider to be a typical base course, which is usually a granular or crushed stone base course. And that subbase that is being created is you're creating a base structure out of the native clay soil in place prior to the base and the overlying pavement layers.
So one thing that we know in Texas is that, particularly when you're talking about along the I-35 corridor and going east, we have a lot of really heavy clays that are highly expansive clays that cause a lot of problems in the construction industry. So clay has some really unique properties to it. It's very, very fine-grained material, and that's why we'll talk about today about how lime is really uniquely suited for treating those types of materials. We're going to spend quite a bit of time talking about TxDOT's treatment guidelines for soils and base and pavement structures. You can find these online at the TxDOT's website, and there'll be a link shown here on the screen where you can go to and download these guidelines. Are available, and the Materials and Test Division at TxDOT maintains these guidelines. These were really developed over years of research through basically two universities, primarily University of Texas and the TTI at Texas A&M, where a lot of this information came from. So we'll kind of jump right into the guidelines, and when you're talking about treating soils, one of the first things you need to do is run a sieve analysis and determine the Atterberg limits. Where Atterberg limits is, you hear the term plasticity index, but that's basically when we're talking about a liquid limit and a plastic limit, which are the two values you use and the difference between those two is the plasticity index. those are Atterberg limits. So one of the first things we look at is run a PI on that material, that native material, and determine where it fits into. The other thing we look at is the grain size. So when we're talking about base materials, you can look on the screen here and see on the left-hand side, base materials will have less than 25% passing the number 200 sieve. Whereas when you get into subgrade materials, they're on the right-hand side of the screen. Subgrade materials are typically going to have more than 25% passing the 200. So I'll talk a little bit about base materials, and we'll kind of go back and forth here and talk a little bit about some of the differences. But the grain size and how much clay is in there has a lot to do with what treatment guidelines or what treatment recommendations you would be using here.
You know, when this TxDOT guidelines for treatment is a pretty comprehensive document, and I think the key is that it is a guideline. It's trying to show you that in various ranges of soil conditions or base material type conditions, you have different alternatives based on the characteristics of the soil. And one of the things on this slide, when you look at, I think that I've gotten a lot of questions over the years, is that when you see the different plasticity ranges, like take for instance the subgrade soil plasticity range of 15 to 35, you can see that TxDOT has a number of what they consider proven or specified treatment stabilize reagents that you can utilize in that. And but I think that the important thing about this guideline is it steers you to what types of treatments you may be able to use in those ranges. And I always focus on the right there under subgrade, that 15 to 35 PI range. You know, you could read that and say, okay, so if the soil is between a PI of 15 and 35, I can just sort of pick any of those. And that's really not what the guidelines, the guidelines is saying that in that range, for instance, that any of these could be suitable treatments, but what the guidelines do is they point you to the testing that's required to make sure that some of those, the soil is always going to tell you which stabilizer it prefers based on tests, and this document is really good about showing you that you have these potential treatments, but that you need to do the appropriate testing, determine which one is best for the soil. And I just think it's important to remember that you can't use any of those in that range, but any of them could be used in that range, but you need to do the testing to determine which one would be best. And
the order that they're shown here is the typical rank order of what you would typically use on there. So Larry kind of touched on this. I'll give the example. If you look at the base material that says there's a PI of less than 12. So if you're looking at base materials, most of the time you're going to use something like cement or something that works really well in coarse grain materials. Right. So on the left-hand side of this chart, you're talking about coarse grain. So it shows that lime, there's on the bottom of that one. The vast majority of the time, lime is not going to be used in a base material or is in a very low PI environment where you don't have much clay. Now, there are some exceptions, so it shows lime in there, but it doesn't mean, hey, lime works just as well as cement in this application, because as we get into some of this discussion, you'll find out that for lime to work properly, it has to have clay. It has to have fine grain materials. In particular, it has to have silicon and alumina, which you don't get out of coarse grain materials. Right. So.
Some bases are what we call dirtier, and so they may have a fraction of that overall base that is clay, and so we will see lime can be used to combat the clay fraction of that base material, but it'll still be used in conjunction with some other additive to get strength and those types of things in that material.
Right, and so when we typically when you see lime used in base, it would typically be like in South Texas or some parts of West Texas where you have like caliche base, which is really a base material, but it does have, as Larry kind of said, dirty. It's got some clay contamination in it. So that's when you'll typically see lime used. But otherwise, you're going to see things like cement, fly ash, or even asphalt. If you have use asphalt stabilized base is very common when you have low PI materials. As you get into the higher PI in that second category under base where it says the PI is greater than 12, you'll see that lime and particularly lime cement moves up that list, and cement moves down to the bottom of that list. So as you get into more higher PI, that's when you're typically going to rely more on the use of lime and less on some of these other stabilizers. Now, where lime really comes into play a lot more is more on the right-hand side of this chart, where you look at the PIs, and they'll range anywhere from low PI all the way up to above 35. Engineers in Texas will tell you we have some of not only the worst clays in the state, but we have some of the country. We have some of the worst clays in the world in terms of this high PI, nasty clays that are difficult to deal with.
The thing about our clay soils in Texas is that they swell significantly when they're wet, and then they shrink significantly when it gets dry. And the way the rainfall happens in our state is it would be nice if rain and moisture stayed uniform, because then that clay would stay at what we call its optimum moisture content, where it behaves a little bit better and you can even get some compaction and things like that on it. The problem is our rain comes in huge deluges, and then we go through long periods of drought, and so that is the worst conditions for clay.
That's exactly right. When we see expansion pressures with clay, you can see 30,000 psi expansion swell pressures, which are enough to. You've even seen on brand new concrete pavement sometime, it's enough to, if you've got that high swell pressures, it's going to move anything, including if it's an apartment building, if it's a pavement, whatever. If you haven't properly treated that clay, it's going to move at some point. So on the subgrade side, we're talking about, again, so very low. If you have it's a subgrade, which means it's a lot of material passing the 200, but it's not high PI. So if it's less than a 15 PI, TxDOT guideline here is still going to say use cement would be your first choice. And as you go down the list, you get into lime. Now there is a range, like that sometimes Larry kind of touched on this, that you may use cement, you may use lime, and sometimes you need to do additional testing to see exactly what that material is in some of that middle range. Most of the guidelines are always going to say that you're going to use lime in those areas. There are some lime cement combinations that can be used there, or lime fly ash, or fly ash even by itself, and as you start to see, as you go further to the right-hand side, cement can still be used up to, it shows on here, 15 to 35 PI material. As you get a little bit higher on the PI range, the cement actually drops off the chart. So anything above 35 PI is almost always going to be recommended to use lime or some version of lime cement together, or lime fly ash together. So
right, and then again, that goes back to just the makeup of that clay. We have, when you look at the classification system for soils, there are clay sands, there are sandy clays, but as you get into the pure clays, and when you start getting above 35, and when you get into PIs that are 40, 50, 60, you really start looking at, they're really pure clays. And so the higher that plasticity index goes, the more you are directed to use lime, because it doesn't have some of the other constituents in it that are treatable with cement or fly ash, things that it doesn't have those kind of granular materials in it that cement and fly ash will bond with. It really is more like silicon alumina, which is what makes up clay, and that is what, of course, calcium oxide, which is lime, reacts best with.
And I think the main point of this whole chart here is, if you remember one thing, is the coarser materials. Lime is going to do very little for you for coarse materials. You're looking at something, cement or something else to bond up coarse grain materials. As you get into extremely fine grain materials, which is what clay is, lime, that's where lime will work. So if you put lime in a material that's got 5 PI, you're not going to get anything out of it. In fact, you may call your salesman and say, hey, this lime is not working. Well, we'll tell you lime does not work without silicon alumina in combination with it. And conversely, when you get on the really high PI side, you'll find that, yes, cement can work up to a certain point, because cement does have some amount of calcium oxide in it. However, as you get into the pure clays and the really expansive clays, you're going to want to look at focus primarily just on use of lime, because just the way the material
it's really the chemistry of it. When you're getting in the lower PI materials and the more granular materials, you're really trying to bind those together and to give them strength and to put those materials together. When you're getting into the higher plasticity clays, you're actually looking to create a chemical reaction to do something and change that clay material into really another product.
Yeah, that's a good point to bring up, Larry, because like some of these materials, even like asphalt, if you on the base side, and even the cement, what those products will tend to do more is encapsulate coarser grain materials. They do a great job of doing that. What lime does, it basically completely consumes the clay. So once you lime stabilize the clay is not there anymore. It basically becomes completely consumed and transforms into a different product that's through the pozzolanic action. So. Right. So these are the basic guidelines, but the main thing, remember, moving from left to right, you're going from coarse grain to fine grain soils, and there's not a one size fits all. And if anybody ever tells you that, hey, our product, there are people out there that will say we've got a great product for soil stabilization. It treats anything from a coarse grain soil to a really fine grain. Typically there's not a lot of truth to that. There's just nothing that does everything. So. Yep.
I haven't seen one additive that works in every single soil profile there is out there. And as Dale's already mentioned, we in the lime industry, we do not promote lime where it doesn't have a chance to work, and you have to have the chemistry for it to have success at working. So one size does not fit all, and also I don't know of any additive that works perfectly in all soil profiles.
Right. So this next slide is kind of it's almost a repeat of that other one graphic, but it's a little bit different. It's going to show if you break the material into looking specifically at gravel, silts and sands, and then clays going from left to right. Again, that's moving from coarse grain material to fine grain material. And again, if you look at the gravel over there, you'll see that lime's not recommended at all in that category. Typically it's not. I mean, there's some rare occasions where you get in the silty sand where you can start getting some areas where that lime could start to help you. But generally speaking, in gravel, you're not going to get a lot out of that. You can use asphalt. You can use Portland cement. Works excellent in those kind of materials or coarse grain materials. Or you can use like lime fly ash combinations. But the only way that lime will work is if you get something that has alumina and silica in it. So you have to get the fly ash, which what that brings into it to form pozzolan. So. Right,
and a lot of times the lime will be a catalyst for a fly ash, and you get that kind of a reaction. But again, when you talk about gravels and going back to the soil classification, if you've got a clayey gravel is a type of gravel. It's one of the classifications, and if you've got a clayey gravel, it'll have a fraction of that overall weight or overall volume of that clayey gravel will be clay, and so that is when you will see something like lime being used in a smaller dosage in conjunction with another stabilizer. So the lime is going to address that clay fraction of that clayey gravel, but it's not going to bind together that gravel and make it a strong structure. Its real purpose is to go in very specifically and deal with that clay fraction of that clay gravel. And I think that's kind of what's important. I think that's when you see lime down on that far left side in gravel, it's being used. If you have a pure clean gravel, lime won't have any function in that gravel. But if it's, well, I say dirty, but if it's got any kind of clay fraction, that's the only reason you will see lime on that far left-hand side. I think that's really the distinction important to remember.
So moving to the right-hand side, if you look at the pure clays, then it's just the opposite situation where you'll see where lime is generally recommended. TxDOT's guideline says if the PI is above 15, there are some national guidelines that will say PI above 10. I mean, you can argue them with it, but that's still relatively low PI all the way up to, and we show only a PI of 40 here. Well, the the clays that we see in Texas, it's very common. You see 40s, 50s, 60s, 70 PIs. Not uncommon at all, where you see those where you almost exclusively get into that lime is really the only thing that's going to really work in that situation. Asphalt is primarily only used when base materials are very coarse grain materials,
right.
and you have a PI of less than 6, so you don't typically asphalt stabilize anything that has a very high PI. The Portland cement here is recommended. TxDOT guidelines is anything below a PI of 15 could be used as Portland cement. And there is a crossover area you'll see there where TxDOT says above 15 is lime and below 15. Well, there's no absolutes. There are, that's not to say that there, like Larry gave the example, that there are some exceptions in that range, but for the most part, we're looking at the extremes here of what works best in those types of materials. So,
and I think that the thing that is really important, and I know we mentioned it just briefly earlier, is that and I think again it's really guidelines. It's telling you that these additives might work in this range, but you need to do the testing to determine which one would work best. And the soils, a soil could have a PI of 18, and they could behave completely differently in terms of which additives best give them strength in the properties you want as a layer in a pavement layer or in a foundation layer.
And I think you kind of said it, but you could have two soils that have their PI of 18, and they can be completely different.
Yes. Yeah.
And so
So it's the mineral, and that is the case too. As you get up higher in the plasticity index level, a lot of people say, well, so if it's got a PI of 40, it needs 6% lime. That may be true. It's true. It's often true, but there has been some really good work done by Texas A&M at the Texas Transportation Institute that really looked at plasticity index of 4 different clays that had basically the same plasticity index, but the dosage of lime to actually change that material and give it the properties it needs to not swell and to give it permanent strength had different dosages of lime. So even using the same additive, lime, for instance, in a high PI clay, you still need to do the right testing to determine what is the proper dosage to get you stabilization of that material. It can vary.
And one of our future podcasts will go into the whole design procedure, the Eads-Grimm test procedure, what's called a lime series, of how you determine how much lime, if you're going to use lime, how much you're going to use. So it's not just a cookbook recipe. I think we'd interviewed Dorothy previously, and Dorothy was telling me on the drive up here that when they first started, everything was 6 inches at 4% lime. Mm-hmm. Back in the 1950s, every stabilization job that they did. And so nowadays, I said, we actually have a design procedure that we go through in the lab to figure out exactly what you need. But one of the things I want to point out about this graphical is what you don't see. You don't see, you don't see things like liquid stabilizers and some of the polymers. There's some alternatives, I'll call them alternative stabilizers. At this point, TxDOT, these are TxDOT's guidelines, and they have none of those other ones have been accepted and turned the mainstream yet. There are some of those that are used for waterproofing or for dust control. Or for have some specific uses, but generally speaking, the two main ones that are used are basically lime or cement, and it has to do with the coarse grain, and those are the only two that really cause a positive lime fly ash. And we'll kind of come back to that in a minute. But fly ash used to be a lot more prevalent. Fly ash has gotten more and more difficult to get a hold of and more expensive. I mean, it used to be a more readily available waste product. Now that we don't have as much coal production, we're starting to see difficulty with people getting fly ash. So we're not seeing as much of that happening anymore as what we used to. But all of those things, at least those three, lime, cement, and fly ash, all do one thing. They cause pozzolanic reaction, which basically essentially makes a cement out of the roadway. They do it different mechanisms, but anyway, I just kind of wanted to mention that there's not 10 different options when you're talking about high PI clay, or even 10 PI options when you're talking about sandy gravel.
That's right. On the alternative stabilizers, as we call them, that kind of present themselves, and TxDOT is only going to approve a product that it can take it in the laboratory, take actual soil that you're going to treat, test it, and get performance criteria off the test results to ensure that it could be used and it's reliable as a structural or a subbase or a base layer in a pavement structure. And so until an alternative stabilizer can meet those criteria, TxDOT is just not going to approve it. I mean, that's really the bottom line.
Yeah. That's really all we wanted to cover today with this kind of introduction to TxDOT's treatment guidelines, and just to let you know, it's out there on the website. If you haven't seen it before, it's a very useful tool to go to and look at. It's a really good starting place, and then if you have questions, you feel free to call me. My phone number is on the final slide here, or call Larry, or it's one of the guys with Texas Lime or Austin White Lime. Any of these guys will be able to help you to kind of get a better understanding of what you need for the given situation. So.
Yeah, and you just kind of echo what you're saying, is I would really recommend that you go on TxDOT's website, and it's a downloadable PDF. I mean, that guideline document, if I recall, I helped review it the last couple go-rounds. It's with TxDOT. I think it's 48 pages long, but you can just find that document, type in that title, which is on one of the graphics that we just showed. It'll pop up, and you can just save it as a PDF, and it's got a lot of really useful information in there. Points you in the direction, and we're not talking about it today, but it does go through the various testing for each type of additive that you would perform to determine if it is a viable additive for a given soil situation or base situation. So it's pretty straightforward.
Yeah, the one thing, and we didn't really, as you mentioned, it's a lot more comprehensive document. We didn't cover everything today. For example, their guidelines are going to say that one of the first things you do is test for sulfates and organics. Yes. So that's a very, very critical, particularly if you're using lime or cement, anything that's a calcium-based stabilizer. When you get into high areas that have high sulfates, there's a whole different appendix. We'll deal another podcast later on how you deal with sulfates, because that's a whole nother lesson. But
no, it's important. I'm glad you brought that up.
Yeah, same thing with organics is that.
And there is a whole mitigation strategy in that guidelines, and goes through some of the ways you would go about determining if you're going to be able to use a lime or a cement, as you said, any calcium-based stabilizer. But it is definitely there are certain areas in the state that have the ability to have high sulfate soils. And you do want to make sure you're checking that before you use lime or cement in a calcium-based stabilizer. And that document is good. And as you said, I think you'll cover that in some future podcasts that really look at sulfates and organics, to things that happen, need to be dealt with, or can happen.
Okay, hope you learned a little bit something new about soil stabilization today and some of the guidelines. And feel free to give us a call if you have any questions. And we appreciate your time today.
Thank you. Thanks, Dale.
Thank you for watching this episode of our podcast. If you want to learn more about the use of lime, reach out to us on our website at limetexas.org. You can also email me at dalerand@limetexas.org. And please follow us on LinkedIn or Instagram, and subscribe to our YouTube channel. Thank you for watching.